Hello, Mr. Mail here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on z-scores and normal distributions. In particular, we're going to start finding areas and values in a normal distribution and that isn't in ways using an empirical rule. So, here's a scenario that we might want to consider to start. And if you like this video, hit the like button. So, Mr. Malo's statistics class conducts an experiment where everyone tries to stop a stopwatch at exactly 5 seconds. Students each record their stop time in seconds to the hundredths place. Turns out that the class results follow a normal distribution with a mean of 5 seconds and a standard deviation of 0.2 seconds. And if I want to ask a question in like this, can the empirical rule be used to define the percent of students who stop the watch in less than 5.05 seconds? So the empirical rule let us kind of cut up our normal distribution to know the areas in certain sections of it. Unfortunately, 5.05 seconds is not one standard deviation, but only a quarter of a standard deviation above the mean. So I'm not going to be able to use the empirical rule here. So we need to come up with a new approach. Now, there's going to be two pictures we have in this approach. You're going to have our unstandardized picture. So these were the same types of pictures I drew in my last lesson. And we're going to have our standardized picture. And the standardized picture is just what happens if we were to run all our data through the formula for a z-score. So we'd standardize all the values in our curve, and it's going to give us another distribution, a normal distribution, this time with a mean of 0 and a standard deviation of 1. So a lot of time I like to write z-score to emphasize what's going on in this picture. So we can take our distribution, our unstandardized distribution that's in seconds, and standardize it to be in terms of z-scores. Now, how do I answer this question I want up here? So I want to find what percent of students stop the watch in less than 5.05 seconds. So 5.05 seconds is going to be here, 5.05. And I know from last time, if I want to answer this question, I'm looking for the area to the left of 5.05. Well, I'm going to find the z-score of the value 5.05. So whatever the z-score is going to be. And then I'm going to say, well, the area to the left of 5.05 in my unstandardized distribution here is the same as the area to the left of my z-score in my standardized distribution down here. So I am going to find that z-score first. So I know that our z-score is value minus mean divided by standard deviation. So in this case, from our unstandardized picture, the value we have is 5.05. So that's what we're interested in. Our mean was 5 and our standard deviation was 0.2. So that leaves us with a z-score of 0.25. And that makes exact sense. Like I said, we knew here that 5.05 seconds is just a quarter of a standard deviation away from our mean of 5. And since that's above our mean, it's positive. Our z-score is exactly just how far above or below the mean you are in terms of standard deviation. So we get that there. Now what we need to do is use some sort of special table. So we don't have enough tables to create unstandardized tables for all our scenarios, whether it be this seconds activity, tests, or whatnot. So what we've done is we have a standardized table to find our solution or our area down in this bottom picture because we know that area will be the same as the top picture. So here's a table. So this is a standard normal probabilities table. You can find them on the internet. You can find them in most textbooks. The one thing you need to make sure of, some tables will give you the area to the left of a z-score, like it's indicated here, but some will give you the area to the right. So just be careful which table you're using and know, because that might deal with some subtraction or addition if you need it. Now, in our problem, we need to find the area to the left of our z-score of 0.25. Now, the way these tables work, z-scores are on the outside of the table, and all the 4-digit numbers you see on the inside are our areas. Now, I'm going to keep scrolling down because I have a positive z-score here, so I'm going to go to the positive z-score table. And since the z-score I was interested in is 0.25, I'm going to go to this is going to tell me I'm going to go to the 0.2 row, so the 0.2 row, so right here. And the 5 is going to tell me to go to the 0.05 column. So the 0.05 column. And that overlap is the area to the left of our z-score there. So in this case, this area is 0.5987. So if we go back to our picture, this area is 0.5987, which in turn means our area up here is 0.5987. So area. Now, and I'll write my z-score 0.25 here. So, what this tells us is that 59.87% of students stop the stopwatch in less than 5.05 seconds. So, this is what we have here. And if you're going to be taking an exam, for instance, the AP exam, what you want to make sure you include on any of your work for problems like this is the following. So, you want to make sure you have both your standardized and unstandardized pictures here. And you want to make sure you do include both the picture and this labeling. You need to make sure you include your work for a z-score. And then you need to make sure you include your final answer down at the bottom. So there's kind of 4 things you need to make sure you are showing. And this is just a guarantee on an exam like the AP Statistics exam that you would get full credit. And even if you're not taking a class like that, this is still good practice to show as much work as possible. So let's do a few more problems now. Maybe you're interested in the percent of students that took longer than 4.82 seconds to stop the stopwatch. So again, you start by drawing your 2 pictures. So you can label and mark your unstandardized and standardized pictures. And in this case, we're interested in students that took longer than 4.82 seconds. So I'm going to put a little X value up at 4.82. And since I want longer than that, I'm shading the area to the right of that value. Now, to answer this question, because we want to find what this area is, we are going to go to our standardized picture because we don't have an unstandardized table for stopwatch values. We do have a standardized z-score table. So we need to start by finding what's the z-score for that 4.82 seconds before we can go to that table to find this area. So again, apply your z-score formula. So value minus mean over standard deviation. So 4.82 minus 5 over 0.2 is your standard deviation to get a z-score of negative 0.9. So that means that value of 4.82 seconds is 0.9 standard deviations below the mean of 5. So you want to know how to interpret those values. So right now, if we're keeping tabs on a grading system, we've done 3 phases of answering our question. Now we got to go back to our z-score table to find the area corresponding to a z-score of negative 0.9. So I'm back at my table here. I'm going to scroll to my negative z-scores, and I'm going to go to the negative 0.9 row. And since my z-score was negative 0.90, I'm going to go to the 0.00 column. So right here. And that means the area to the left of my curve at that value is 0.1841. So if I go back to my picture, the area to the left of my z-score is 0.1841. So I have 1 minus 0.1841 to give me everything to the right of that. And that's going to give me an area of 0.8159. So since that's the area to the right of a z-score of negative 0.9 in my standardized picture, that means the area to the right of my value at 4.82 seconds in my unstandardized picture is also 0.8159. And what that means in context of our problem is that 81.59% of students took longer than our 4.82 seconds to stop the stopwatch. So similar type problem here. We could up the ante a little more. Maybe you're interested in answering a question between two values. Still doesn't matter. We have the same process. We want to label our two pictures, so our unstandardized and our standardized picture. Then we got to mark up the different locations we want. So we want the percent of students that took between 4.9 and 5.25 seconds. So I've marked up my two places on my graph, and I want to find the area between these values. So I have kind of two values here, so I'll do x sub 1, x sub 2. That means I'm going to need the corresponding z-scores, which I'll call z sub 1, and I will call z sub 2. So this is the first step of our problem. We've kind of marked up our two pictures here. Then we move on to the third step. We need to find our two z-scores. And again, we go back to our trusty formula. Z is equal to value minus mean over standard deviation. So we're just going to do that for each of our values. And we get our first z-score value corresponding to 4.9 is negative 0.5. So we got negative 0.5 on our standardized picture. And the second value is not 0.2, it's 1.2. Sorry. So we have, 1.25, my bad, 1.25. So that means we're going to try to find the area between these two values in our standardized picture, because we have a standardized z-score table we can look at, but not an unstandardized table for seconds. So if we can find this area, then we'll be good. The easiest way to do that is going to be to find the area to the left of our z-score of 1.25, and then subtract off the area to the left of our z-score of negative 0.5, because that would take away what we're counting or in our original number that we don't want. So we can go to our table. So for the area to the left of the z-score at 1.25, we're going to go to our 1.2 row and the 0.05 column, and we find that our area is going to be 0.8944. So in our picture, the area to the left of our z-score of 1.25 is 0.8944. Now, we don't want the area to the left of the z-score at negative 0.5, so that's what we're going to subtract off. So we go back to our table, and we say, okay, we're done with this z-score. We're going to our negative side, and we want our z-score of negative 0.5. So I'm going to the negative 0.5 row and the 0.00 column. The area to the left of the z-score of negative 0.5 is 0.3085. So we're going to subtract that off from our area of 0.8944 to give us an area of 0.5859 between those two z-scores, which means the area between our two x values in our first picture is also 0.5859. That is our area. So, lastly, you gotta make your interpretation. What does this mean for us? And it tells us that 58.59% of students took between 4.9 and 5.25 seconds to stop that stopwatch. So it's a lot of our students in that interval. So these questions are all pretty much the same. The only variant we might have early on is if I don't give you a value to begin with. So in a problem like this, I want to find out which students jumped the gun. So you had an itchy finger and clicked too early. So you stopped too early. What would put students in the 10th percentile? So 10% or less of them ended up clicking and the watch really fast. So first thing we gotta do is mark up our pictures again. But now we want to begin by highlighting the area to the left that's going to represent 10% because we're interested in the 10th percentile. Now, by the empirical rule, you know that 10% of the data is going to, if I want that to be to the left of my value, that value of x that I'm interested in is going to fall somewhere in between 1 and 2 standard deviations away from our mean. So this is the x value we're interested in finding. So I'm going to put a little question mark there, because this area is going to be 0.10. So what we're going to do is we're going to find the corresponding z-score value using our z-score table that we get 0.10 as our area. So area. And to do this, we're going to kind of read our table in reverse now. So we are going to read our table in reverse. So to do that, we're not going to start by finding in the z-score row or column. We're going to hunt in the middle of our table for what's closest to 0.1. So when I go to my table, I can kind of quickly scan to find where are the 0.1s, and I can find them right around our z-scores of a negative 0.3, negative 2.2 range. And I'm going to find that I transition from a z-score of 0.9 to 0.1 right around here. So I'm going from my 0.1s to 0.09s right here. So since this z-score of 0.1003, or this area, of 0.1003 is closer to 0.1 than 0.0985, I'm going to take the z-score corresponding to this value. So z is equal to negative 1.28. And that does fall between 1 and 2 standard deviations below the mean, just like I expected. Now, if you don't like taking this value because it's a little bit off, what some people will do is actually average the two z-scores here. So the negative 0.2, negative 1.28 and negative 1.29, they might take the difference to take a z of negative 1.285. It's fine to just take the one that's closer though. So I'm going to take negative 1.28. And I'm going to go back to my table now. So I got negative 1.28 for my z-score. Negative 1.28. Well, I'm going to reverse engineer to get my value now. So, again, this is now stage 3. I'm going to use the fact that z is equal to value minus mean over standard deviation. I know a z-score now, negative 1.28. I want a value x that I don't know. I know the mean is 5. I know my standard deviation is 0.2. So I can rearrange to solve to get x is equal to 4.744 seconds. So what that means, and step 4 is kind of stating what my answer is here, is that a student who stops the stopwatch at 4.744 seconds is at the 10th percentile. So that means anyone who stopped it faster than that, you pulled it way too fast, pretty much. So these are the types of problems we're going to answer with it now. So kind of the key things you want to take away. Values that are not 0, 1, 2, or 3 standard deviations away from mean are going to make us have to use the z-table or test some technology that I'll show in another video how to find the probabilities. you need to make sure you're denoting your normal distributions using the mean and standard deviation. So I'm going to have 2 for each of these problems. My unstandardized one, which uses the mean and standard deviation given in the problem, and my standardized distribution, which is always going to have a mean of 0 and a standard deviation of 1. You need to make sure you know that the area given by your z-score table is to the right or the left of the value. Look to the picture at the top of your table to know which type of table you have. They'll be different depending on what you're given. And z-score tables are only going to be useful if the unstandardized distribution is normal. If you're not working with a normal distribution, then this stuff that we just did doesn't matter. You can't use that table. So I hope you found this video helpful. If you did, smash the like button and have an awesome day.